Welcome to episode 4 of our YouTube series on motor testing. Today we're going to be looking at back EMF testing. That's where we spin our rotor and look at our induced voltages. Before we start looking at back EMF testing itself, it's important that we understand what back EMF is. Back EMF is the voltage that's induced on the coils as the rotor begins to spin. So if we look at our drawing here, that would mean that this would be a one-phase coil and this would be one magnet. Now, as this begins to spin, we create a changing magnetic field in our coil. That changing magnetic field induces a voltage. And if we look at measuring between the two coils, as we know, in a motor we have a star point, and we can read off between this point here and this point here, we'll start getting a sinusoidal wave, like so. The last important thing to note is the relationship between speed and voltage. So if we plot with our x-axis speed of the rotor and on our y-axis voltage, we'll see that as the speed increases, the voltage increases too, and that has a linear relationship, so we see a straight line. This is something that's really important later when we look at the data analysis of the results. So now we're going to run through the test. As you can see, we've got our motor under test here. We've got a stepper motor which will spin the shaft, and then we've got our scope attached to one of the phase ends, grounded to another. So we've got our phase to phase. Okay. So now if I begin to run the motor, you'll start to see the voltage output on the scope, and if we pause that and turn the motor off, we can start to read some of the outputs. Now we can start to analyse the data. So as you can see here, I've got a screenshot of what that results were. Now, and obviously in actual fact, we'd run this test 3 times looking at all the different phases, but for this case, we'll just look at one different phase. Now our key information here is this one here, which gives us our maximum voltage or our peak voltage, and here, which is our frequency. Now, we know about this machine is an 8-pole machine. We know that the maximum voltage is 26 volts, and we know that the frequency is 19.2 hertz. So now we know that information, the first step is to use this simple formula where we do frequency equals speed times poles divided by 120. Now for this equation, we know our frequency and we're trying to calculate our speed, so we can rearrange this to get frequency times 120 divided by poles gives us speed. So now taking our results from the test, we'll apply that to this equation. So we've got 19.2 times 120 divided by a pole number of 8, which gives us a speed of 288 RPM. The next step is to look at the back EMF constant. So in this case, we know that we have a peak voltage of 26.0, and we know that our RPM is 288. What we want to do is divide by that 288, which gives us a value of 0.09028 volts per RPM. We can now use this value to evaluate the performance versus previous data for the same motor, also against simulated data, as well as the different phases to ensure that everything is balanced and correct. So that's it for our episode on back EMF testing. Today we've looked at the theory behind back EMF and what it is, we've looked at running the test, and then we've looked at analysing some of the results. And unfortunately that finishes our series on motor testing. Over the course we've looked at some of the winding tests, we've looked at the back EMF test, but if you've got any more questions, just drop them in the comments below and we'll look to try and answer those.